Hey, welcome back to Fat Mama Physics. In this video, we're continuing with Unit 3, 3.2, which is adding polynomials. We're going to use the skills that we learned in our previous lesson on like and unlike terms to help us deal with cases where we are adding polynomials. Not very hard at all, but let's take a look. Oh, yes, and of course, our accompanied board game for today, which of course has to do with adding polynomials and identifying like and unlike terms. So let's begin. Onto my camera screen. All right, so what I have here is a very awesome game called Legendary. It's a deck building. This one is a cooperative deck building game. The one that is the most common version is, it's Encounters, but it has to do with the Marvel series, Aliens and Predators and all that like. This one is more of a spin-off, and my husband and I enjoy watching Firefly, so of course we got this one here, which is Legendary Encounters Firefly Edition. But if you like Marvel, Upper Deck also makes the Marvel version as well. So in this co-op game, this is our board. It's a nice quality mat, very nice. And let's talk about what we have here. So here I have two characters. I have kind of picked the main characters here. We have Mal and Zoe in the series, if you watch it. So here we go. There's him, his health, his shield, his abilities. Same thing here with Zoe. And of course, their deck of cards. I forgot it was 6 or 5 cards, but I'll just draw them now. And their deck is made up of shinies, which have money value, and scratchies, we call them misbehave. So these scratchies, of course, causes damage. Okay, so this is their hand of 5, which I only have one hand to kind of do stuff. And usually we play 3 storylines, and every storyline has an accompanying set of cards, and I've chosen Ariel, which is one of my favorite episodes, Ariel. There are 2 objectives we have to accomplish, which then, of course, the event deck will produce whatever we need to do. And so here we have the things that we can buy down over here. So we can buy these brown coats, which we can see the cost down there, and this also gives us additional amount of money or scratchies or whatever. Coordinate is a very awesome mechanic, which then allow you to play this on someone else's turn, so that you can give them the money. And anytime you play Coordinate, you of course draw your hand back up to whatever. The also good thing about this is provides a symbol, which I'll talk about in a second. Okay, so things are here to buy. So for example, let's say the turns get rolling. I'm gonna skip the specifics, but essentially what happens is that as the turns go by, things start popping up in the verse. And in order to flip them over, we have to scan them, which causes scratchies. So this causes 4 scratchies, 3, 3, 2, 2, respectively. So every turn, if these are not scanned or dealt with, they move down, and then they keep moving down until if you don't do anything, then they're going to, the turn that the new card is flipped, this comes into the combat zone, in which you have to deal with, which usually is not good. Whoopsies. I'm not supposed to see that. And usually you might want to scan anything that's up there in order for you to achieve the objective. So you don't want things to come popping up into your combat zone. You kind of want to deal with them beforehand. Okay, so that's kind of the gist. And every turn you do any sort of buying action, any sort of hitting actions, and then that's kind of the end. Of course, buying is great, and then this is getting towards what I want to talk about, which has to do with matching and adding up of effects. So here we go. I'm gonna put it in close range so that maybe we can see a little bit better. So if you take a look at some of the cards, they have these symbols, including these brown codes. So you have blue, you have yellow, you have a tech, you have punchy, and you have I forgot what that symbol means. But anyways, I picked a very common, very simple one. I picked the punchy punchies, which are great because they have a good way to combo with each other. So take a look at the things to buy here. We have different cards. They offer different amounts of scratchies, and maybe they might allow you to buy certain things. But especially if you have a card that looks like this, if you have a green punchy punchy, it means that if you play this card with another card that also has a punchy punchy symbol, which is not itself, you can activate this text down here, which is defeat a shiny in any player's discard pile. You might think, oh, you're destroying your own cards. It's not really a good thing. Shinies are the crappiest cards in your deck because you'll get better cards over time, and you always want the ratio of good cards to bad cards to be obviously higher, so the chance of drawing a good card is higher. So here we go. There's this one, and here, this card here, if you match a green symbol, a punchy punchy, from another card, then that allows you to get 2 additional scratchies to what she has, or this card has here. So that would be 2 plus 2, a total of 4 scratchies, which is pretty good for if you can combo like that. It'd be pretty nice. So it looks like buying these set of cards all together would be very helpful because all of them have punchies. And which is what I like to say about the essence of matching symbols and adding up their effects. So for example, let's say someone got, let's say this person had all 3 of these cards in their hand at one point, which happens maybe later in the game, not right away. Then this person might be able to say, hey, I have this card, and I have these other cards with the matching symbols, and this particular card, I can use this symbol for this as well as that as well. It's not considered, I can reuse it if you think of it that way. So in this case, I can activate both of these green symbols, in which my total amount of scratchies, in this case, that doesn't activate because I'm probably not Simon as a main character. So that's 3 plus 2, 5. 5 plus 4 is 9. I get 9 scratchies, which totally defeats this guy. Enemy has, if River's a main character, plus 2 is Simon. No, none of them are main characters, so that totally defeats him. Which is greater than 1, okay? And then I also get to do this, which is defeat a person's shiny hand. So that's what I mean by the symbols add up. If you have symbols that stack on top of one another, which allows you to activate these bonus effects. So it's like adding up of effects, just like how you would add polynomials together. Now imagine down the road here, as these brown codes are being bought, there's actually a green one. So the nice thing about coordinate is, let's say a person only has this card in their hand, this one here, and does not have another card with a punchy punchy. Let's say their partner drew this and had it in their hand. They can dump this card and use it as a coordinate on top of their friend getting $2. All this card also supplies that green punchy symbol, which allows them to activate this here. So that's one thing that's powerful about coordinating in this game, which is one of the mechanics I enjoy. So that's another cool thing about matching, is that you can match yourself, and then if your friends, partners also have the coordinate with the right symbol, also allows you to activate certain effects, which is fantastic. So that's kind of the and of course, after you achieve the objectives, you get the credits, and then you get the credits, you beat through all the scenarios, then you win the game. So basically, it's a game of, kind of like a game of survival, but it's at the same time achieving your objectives in a way so that you don't die too hard, is kind of the idea, because sometimes if you don't achieve the objectives, it can also be hurtful. So there you go. This is Legendary. I really like it because it's a co-op game, and I'm personally like deck building games as well, and I love the show Firefly, which is unfortunate they discontinued their show. So here you go, matching symbols and adding up effects. Back to adding polynomials. So let's begin adding polynomials. You've kind of added like terms already, which is very similar to adding up like terms, except two big hunks of polynomials are being added together. And oftentimes we show it as two brackets that kind of close them off, so we know exactly what it is that we are adding, which polynomials we're adding. Okay, so let's take a look at how we do this. Taking a look at the horizontal method and the vertical method, I will show both. I mean, it really doesn't matter which way you use it. I actually don't prefer the vertical method because oftentimes once my students go into subtracting polynomials, the vertical method becomes very confusing. So I actually don't prefer the vertical method. I just prefer the horizontal method, and that way it's harder to make mistakes. Okay, so let's begin. I'm going to do A. You're going to do B. Oh, B is a little trickier. Fine. I will... Okay, fine. I will do A. B will be a challenge for you then. All right, so let's do example 1 together. Okay, we have two polynomials that are being added. And if we take a look at the first one, notice that there is no sign in front. There's no negative sign and there's nothing else. So that just means if any time you have something that is in the front of your expression or equation sentence, you can assume that there's an imaginary plus sign. So then when you kind of break the brackets, when you dissolve the brackets, then you get the 3x dropping down, just like this, the 2x, and then the 4. And inside the other brackets, since you're adding exactly what is inside the brackets, all you have to do is you just have to make sure you are faithful to the signs and that you copy them as you see it. So if this is negative 5x squared, you copy minus 5x squared plus 3x minus 5, okay? So you copy that as is. Once you've copied it down, once you've dissolved the brackets, then what you want to do is you want to group the like terms together, just like we did that in 3.1. So I know that 3x squared is the same as minus 5x squared. Don't forget the negative sign. And I have 2x here, which is the same as 3x. And then last but not least, I have the, I'm sorry, I'm not going to be able to show this very well, but I have plus 4 and minus 5. Don't forget the minus sign. And now I can rewrite this in which I have the largest degree terms in the front. And putting them together, I get 3x squared minus 5x squared. The next size up I have is in purple, plus 2x squared, plus 2x plus 3x. Okay, so that takes care of these guys. Oops, I took care of these guys. Oops. And then the blue, I have plus 4 and minus 5. Now I can simplify this. This gives me 3x squared minus 5x squared. So that's 3 minus 5. That's negative 2x squared. Notice just dealing with the coefficients. I have 2x plus 3x. That is just 5x. Last but not least, I have plus 4 minus 5 gives me minus 1. And that is my final answer. Okay? So that's the horizontal method. Maybe you can try B on your own. Good time to pause the video. Alright, B is a little bit tricky because notice in B, not every term is featured in the first polynomial. But again, you dissolve the brackets as you would normally. So let's dissolve that. I get 7s plus 14. Oh, don't forget, there's a minus 6s squared plus s, and don't forget the minus 6. Grouping like terms. I only have the negative 6s squared and no other of that in the first polynomial, so I leave it as is. I do have a 7s and a plus 1s here. And last but not least, I have plus 14 and minus 6 as my last group of terms. Rewriting everything, and of course in descending order of degree, I have negative 6s, that's the only one I have. And then I have, don't forget I have a imaginary plus sign there, so I get plus 7s plus s, and anytime I just have a plus s, there's an imaginary 1 in front of that s. Okay, so that's 7 plus 1, essentially. I have now, what's remaining is I have plus 14 and then minus 6. After I do the addition, I get negative 6s squared. Nothing happens to that. I get plus 7 and plus 1. Don't forget there's an imaginary 1. So 7 plus 1 gives me 8s. Okay, the blues plus 14 minus 6 gives me plus 8. And there we go. This is my polynomial. All right, so that's example 1 for the horizontal method. I'm going to show you the vertical method, but I won't expect you to actually follow me along, okay? You can do it if you'd like to. To be honest, on any quiz or test, I don't care which method you use as long as you don't make mistakes. I mean, that's just the same with anything, right? So let's take a look at how we do that. So we are actually using exactly the same examples we have above, so the answer should be the same. So what the vertical method does, and it is advantageous because you immediately group the like terms right off the get-go. So what happens is I have the 3x squared, I have that right there, and that is already being aligned with the whatever is underneath. The negative 5x squared is right underneath. So immediately you can see how it's in one vertical line for you to be able to add properly. That's the benefit of that. Okay, so let's just finish this off. I have the 2x here. Actually, I should box it. I have the 2x that is positive, okay? The 3x over here as well, so they're also in one line. Last but not least, I have plus 4 and minus 5, okay? So they're all there, ready to go, and all we have to do is just add in an up and down fashion. So plus 4 minus 5, that gives us minus 1. 2 plus 3, both positive, gives us plus 5x. Okay, 3 minus 5 is minus 2x squared. And of course, this should not deviate from the answer that we have above. Now you might think, isn't that just easier? You just stack everything that's the like term, and just add up and down. Maybe good for adding polynomials. When you get to subtracting polynomials, it becomes a little bit kind of a little bit convoluted. It's easier to make mistakes, but maybe it'll work out for you. So I will do it both ways, and I'll tell the advantage of both. I'll tell you the advantage of both. So let's do this one just to complete the thought process here. Let's do the alignment. And keep in mind, notice my first polynomial does not have an s to the power of 2. So when I write my addition sentence, I just have to be mindful that my 7s kind of goes in the middle of all of my other numbers. Okay, I still copy the negative 6s squared over here, the plus s, and then the minus 6. Now, if I want to, I can just be doubly sure just to make sure I show you all of the terms that should be aligned properly over here. So that's the 7s plus this guy over here. And I'm also boxing in the plus sign. Even though it seems redundant, it just makes it more, it just makes it clearer that it's the positive and not the negative. So if we add up everything here, we get 8 here, okay? And then the second one, that's positive. The second one is going to also be 8, I suppose. Okay, this is also going to be 8s. There's double. And then the last but not least, I have minus 6s because that's all there is to it. And this is a positive. Okay, and there you go. That's our answer. And yes, it does seem very easy to do that, but hopefully you'll find your jive with either of those methods. Okay? All right, so now we're done that. Let's take a look at some other examples, especially with shapes, and then we'll do the second video on the second half of the page. Here we go. Example 2. Determine a polynomial for the perimeter of a rectangle. Seems like rectangle is a very common shape for this unit. So I would say it's a good idea to be familiar with the shape of a rectangle, including how to find its area and how to find its perimeter. So let's do A. Write a polynomial for the perimeter of these shapes. So let's begin. We know that the perimeter is made up of the sum of all of the side lengths. So now, do you remember what these mean? And these? And this? Just a quick recap. Whenever you see a dash, and then you see another line with the same style of dash, which is a single dash and a single dash, that means that these two side lengths are exactly the same. So I'm going to call that the oopsies. I'm going to call that the width. Okay, I'm going to call that the width, which is going to be the same on the other side as well. And the two dashes means this length is going to be the same as this length. And I'm going to call that the length of the rectangle. If you see a little box that looks like that, it means that's a right angle. Okay? And once you see all three of these symbols here, it pretty much tells you that this is a perfect rectangle. We know that the perimeter of a rectangle is the sum of all of its side lengths, as referenced in one of the previous videos, which in our case, since there's two lengths and two widths, the perimeter is two of the lengths added together plus the two widths added together. So if we know the length and we know the width, we can complete this sentence here. The length is 3x plus 2. The width is 2x plus 1. So let's substitute that into our equation. So our length is going to be, and I'm going to put in brackets, 3x plus 2. And then my width is going to be 2x plus 1 as written in this diagram. Now, it seems like we're done, but we should always simplify. Even, hey, in the instructions tell us to simplify. So let's go ahead and simplify. It doesn't seem like you have done this one before, so I am actually going to write this all out. I don't expect you to know distributive property yet, but I'm going to rewrite this so that my perimeter is an actual addition statement. So 3x plus 2 is essentially 3x plus 2 in brackets plus 3x plus 2 again. Okay, so there it is. So that's 3x plus 2 added to it, well, times 2. It's exactly the same thing. So I'm going to do that with my width. Because I have two widths, I need to add this twice. So I'm just going to do this. Okay, so ultimately this is my addition statement. Yes, it looks kind of long, but it's not too bad. So let's group things together like we normally do. 3x, 3x, 2x, and 2x. And these are all adding, which is nice. So essentially, I have 3x plus 3x plus 2x plus 2x. I know I don't have to really break it down this much, but just so you can see the process. Maybe I'll do it faster next time. So I get plus 2, plus 2, plus 1, and plus 1. And finally, let's add everything together. So this is going to give me 3, 3 is 6, 6, 2 is 8, and 8 plus 2 is 10. Or 3 and 2 is 5, 2 of them is 10. So I get 10x, and here I got 2 2's and a 1. So that's going to be 4 plus 2 is going to be 6. Okay, so I have 10x plus 6 is the perimeter of my rectangle. And it is okay if we don't know what x is. Sometimes our final answer is going to have a variable, and we just have to be comfortable with that. Just like over time, we learn to be comfortable with the unknown, which is uncomfortable, but we have to train ourselves to be like that. So that is A. Let's do B. Okay, B is a little bit more convoluted, but we are told all of the side lengths. So for perimeter, we just have to add them all up. Okay, so let's do that. I'm going to write the whole sentence first, and then maybe in this case, I'll just use the vertical method because I'm running out of space. Okay, so I have 5x. So I'll just add up all the sides here. This is going to be 5x squared plus 7. And then down here I have, actually putting them in brackets are going to be very helpful. But it doesn't look like, oh, there's one minus sign in here. That's okay. Okay, I'm going to add this guy. And I'm going to add it here because I'm going to use the right side later. Plus 3x minus 4. And then notice I'm just putting everything in brackets just to be clear. Okay? All right, so that's my sentence. Now to actually put it all together, so I'll show us the work. And starting with the x squares, just highlighting them all, I get 5x squared, I get x squared, I get 2x squared, and then this x squared over here. So I kind of restricted where I put my polynomial in a sense, but that's okay. Next up, I have the 2x, the 3x, and I believe this is a single x. Yeah, that's a single x. So this guy as well. So the x squared here, I get that plus 2x here. The 2x here is plus 3x. And then the last one here is plus 2x, in which this one up here gets nothing. The last but not least is a constant. So that's this guy, the negative 4 with the negative sign in there. So plus 7, I get to put that here. This next one is plus 5 minus 4, and this bottom one doesn't have anything. So I'm going to add these all together. So 7, 5 is 12, minus 4 is 8. Okay, so I put the 8 here, plus, because it's positive. And then for the blue, this is going to be 7 plus 7x after I add these all together. 2 plus 3 is 5, 5 plus 2 is 7. Here, don't forget, anytime you have a single x squared or there's no coefficient, it always has an imaginary coefficient of 1. Oops, that should be green. And if I do that, I'm going to add these all together. 5 plus 1 is 6, plus 2 is 8, plus 1 is 9, plus 9x. Okay, so that plus is not required. Okay, so here we go. This is our final answer. Okay, wow, that's a long process there. So there you go. That is adding polynomials. In the next video, we are going to more trickier examples. Very nice. Okay, next video we're going to do more examples on adding polynomials. So I thank you for watching, and see you next time, part 2 of 3.2 adding polynomials, Fat Mama Physics, signing out.